Hello guys, welcome back to the English class. In today's class, we're looking at partial fraction. Another partial fraction for today, I'll be explaining the basic concept that you need to know to solve the equation in partial fraction. Now, in partial fraction, given f of x to be x minus 1, and given g of x to be what? S squared plus 1. Now, in partial fraction, I'll be saying three basic things, but in total I'll be writing 5 things on board. Now, the first thing out of the three basic things I'm going to say is that to resolve the partial fraction, there are 3 things you need to note. When you check the power of your numerator, and you notice that it is less than the power of your denominator. What do I mean? In this case, I have f of x to be x minus 1, g of x is what? S squared plus 1. Now, if I'm going to find f of x over g of x, well, I'm going to resolve this in the partial fraction. The first thing I should notice is that what? My numerator is used with what? X minus 1, denominator with what? S squared plus what? Plus 1. In which case, the s power of my numerator here is what? Is 1. That's x to the power 1. And for the denominator here, the s power here is what? Is 2. That's x to the power 2. Now, as I was saying, if I notice that my numerator's s power is less than the denominator, less than the denominator in terms of power, I'll do what? I'll resolve the partial fraction straight up, which I'll show you in the next video. I'll resolve into partial fraction. That's the first condition. Now for the second condition, when you notice that your numerator's s power is equal, let's say I'm giving f of x to be x squared minus 3x plus 5, and let's say h of x to be x squared plus 4x minus 3. In this case, I've divided f of x by h of x. All I will have my f of x equals x squared minus 3x plus 5 over x squared plus 4x minus 5. In which case, on noticing my numerator's power, I have that as 2. And numerator's power is also 2, where they have the same power. So in this case, numerator's power is equal to numerator's power. What I'm going to do here is what? I'll divide using non-division method, which I'll show us in my next video. I'll divide using non-division method. Non-division. Then resolve into partial fraction. Now that's the second condition. The third condition, which is the last condition, is if I notice that my numerator's s power is more than, let's say, s cubed minus 5x squared plus 3x minus 1, and let's say over I of x, which is x squared plus 4x minus 3. In this case, the power of my numerator is higher than that of my denominator, because numerator's s power, which is function of x, f of x, is 3, and I of x power is 2, x is power 2. In which case, I'm also going to what? Use this same method. So when the numerator's power is greater than the denominator's power, I'll first divide using what? Long division method. Then I'll now resolve into partial fraction. So those are the 3 conditions that I have basically. Now next time I'm writing on board is going to be a process of what I going to resolve the partial fraction, whenever you have a question. Now, for the main things I was talking about, I'm going to write on board is how you can resolve the partial fraction. Now, how are you going to resolve the partial fraction? For condition 1 I said when you notice that your highest power of the numerator is less than that of the denominator, you do what? You resolve into partial fraction. Now, these 2 conditions are as follows. We have the fourth condition to be something like x minus 1 over x squared over s squared. Now, when I have a question like this, and I have my denominator to be having a variable all squared, or a factor all squared, or all cubed, or raised power 4, or raised power, the way it's going to be is what? To resolve the partial fraction, you have to reduce your constants a, b, c up to z. Depends on how large your coefficient power is. Now, in which case, I'm going to resolve it like this. Introduce my constant a is going to become what? A over what? Take the initial power of x squared, which is what? X is power 1, or x, plus take the next constant over x squared. That's all. So this idea is how you resolve this partial fraction. So when I start solving questions in my next video, you see I'm going to use this idea to resolve this question into partial fraction. Now this is this type. Another type is similar to this is something like x plus 1 over what? X minus 1 all cubed. Now in this case, x minus 1 is carrying the power of 3. So I'm going to have that as what? A over what? X minus 1 raised to power 1 as the initial power plus b over x minus 1 raised to power 2 as the what? Second power plus what? C, which is the third constant, over what? X minus 1 all raised to power 3. Okay, so if I now have something like this and this joined together, I'm going to use the same idea. Okay, let's say an example. Let's say I have x over x plus x squared and let's say x plus 2 raised to power 2. In which case I'm going to have a over what? X first plus b over what? X squared plus c over, go to this next one, x plus 2 like raised to power 1, I mean, plus d over what? X plus 2 raised to power 2, and so on like that. Now, the last thing I'm going to put on board is when you have a question whose denominator is not factorizable. What do we mean by not factorizable? If I have something like x squared minus 1, this is factorizable because it is what? Difference of two squares. Where I have that minus 1 squared to be what? X minus 1 times x plus 1. Where if I multiply this, I'll get 2 back. And that example is x cubed minus 9, which is same as what? I mean x squared minus 9, which is same as what? X squared minus what? 3 squared. Difference of two squares. Where if I expand, I have that x minus 3 and x plus what? 3. So, but other questions and other factors that are not factorizable, we are going to what? See how I'm going to express it on the partial fraction. Now, let's start giving number 5. F of x over g of x. Where my f of x is, let's say x minus 1. My g of x is 4x squared plus 3. Now, looking at this, I cannot factorize this. I cannot factorize this because if I equate this to 0, I'm going to have my x to be a negative square root. If I equate this to 0, I'll get x to what? Square root of minus 3 over 4. That I'll get, which is this kind of proper in this case. Now, so the way I'm going to express this, since this is only what is here, a not factorizable denominator, is going to be what? Ax plus b over x, 4x squared plus 3. Let's add one of this to this and see how it's going to be as an example. So let's say f of x over g of x is going to be x plus 1 over what? X cubed times, let's say, x cubed plus 4. Now, this is factorizable. I will express it like this. This is not factorizable. X cubed plus 4 is not factorizable. How will I express this? Starting from here, I have that a over the initial power of x cubed, which is x to the power 1, plus b over the next power x to the power 2, plus c over what? X to the power 3. Then plus, for this one, this is not factorizable. I'll express that as dx plus what? E over what? S cubed plus what? Plus 4. Now that's how to, those are the ideas you need to what? Answer any question in what? In partial fraction. So in our next class also, I'm going to be solving questions on each of them and then showing us the formulas that we'll likely use. Two basic formulas which are cover up method and what? Comparing questions. So that's how to what? Solve questions under partial fraction.